VLAN trunking protocol, or VTP, is a Cisco proprietary Layer 2 protocol that enables VTP-configured switches to communicate VLAN information to each other over trunk links. VTP operation enables a networker to save time in VLAN configuration. Correctly implementing VTP also reduces errors in VLAN configuration across an enterprise network. VLAN configuration in small networks such as this one requires little time or effort from the network engineer. In this case, if VLAN 30 needs to be added to the 3 switches, the engineer merely accesses the 3 switches and makes the appropriate configuration changes. However, in an enterprise environment, VLAN configuration becomes a more complex task and manual configuration becomes less attractive. The alternative is to use VLAN trunking protocol, or VTP. This enables networkers to configure VLAN information on a single switch. That switch then updates other switches with the VLAN information. When implementing VTP, the engineer configures one switch as a VTP server. This server switch is responsible for propagating VLAN information to other switches that are configured as clients. In this animation, after VTP has been configured on all switches, VLAN information from the server is sent to other switches within the VTP domain. To maintain accuracy, Switch 2 and Switch 3 also send VTP advertisements back to Switch 1 showing their VLAN information. A VTP domain is a collection of switches that will share the same VLAN information. VTP switches only exchange VLAN information with the switches in the same VTP domain. When switches are in different VTP domains, they do not exchange VTP messages. When configuring a VTP domain, in addition to designing a VTP server, the engineer configures every other switch in the VTP domain as a client or to function in transparent mode. VTP servers advertise the domain VLAN information to other VTP-enabled switches in the same domain. The server is where VLANs can be created, deleted, or renamed for the entire domain. VTP clients function the same way as VTP servers, but you cannot create, change, or delete VLANs on a client. When a VTP server sends VLAN information to a client, the client updates and stores that information in RAM. Switches operating in transparent mode are neither clients nor servers. They merely forward VTP advertisements from client and server switches. Any VLANs that are created, deleted, or renamed on a transparent mode switch stay local to that switch. One extremely important characteristic to remember about VTP concerns the configuration revision number. The configuration revision number is a 32-bit number that indicates the level of revision for a VTP frame. By default, the configuration revision number is 0. Each time that a VLAN is added or removed, the revision number is incremented. Let's look at a potentially catastrophic situation that can occur if the revision number is not given proper respect. Here we have a VTP server and 2 client switches. Each has a configuration revision number of 17. Through normal VLAN management, this just happens to be the current revision number. If we were to add VLAN 80 to the server switch, the revision number would be incremented to 18, which would indicate more accurate VLAN information than that which is configured on the client switches. As a result, the client switches would add VLAN 80 to their configurations and increment their revision number when they receive advertisements from the server. Suppose, however, that we needed to add a switch to the network and we had a spare on the shelf, switch 4. We don't think much about any previous configuration that might be on the switch, so we plug it in and connect a trunk port to switch 3. Unfortunately, switch 4 used to be a client switch in the same VTP domain, but its revision number happens to be 35. Moreover, the network has changed considerably since switch 4 was in action. Switch 4 has VLANs 30 and 40 from a previous configuration. As you can see, VTP advertisements with a revision number of 35 propagate through the network and delete VLANs 10 and 20 and replace them with VLANs 30 and 40. Any ports that were participating in VLANs 10 and 20 no longer belong to a VLAN and connectivity is lost. Therefore, when adding a switch to a VTP domain, always reset the revision number to 0 by changing the VTP domain name to any random name and then changing it back to the VTP domain name that you are currently using. When understood and used properly, VTP can drastically reduce the amount of time needed to configure VLANs on groups of enterprise switches. It is important to note, however, that VTP does not add ports to the configured VLANs. These additions are still done manually by the network engineer. Nevertheless, VTP is a valuable tool to know when networking in the enterprise.